Okay, so today we're going to be talking about linear relationships in the real world. What does it mean when we're talking about math outside of the math classroom? So when we look at this, now that we know how to find slope and y-intercepts, how does that apply in real life? Well, we can use slope and y-intercepts to describe events in everyday life. Okay, so let's open up our notes so we can look at some different scenarios. All right, before we get into talking about the questions listed below, I want to take a look at just the graph. And I want to notice some things about the graph. What is this graph talking about? Well, the title tells us it's talking about the depth of water in a vase. We know we're talking about days, which that's our time. And our depth is being measured in inches. So when I look at this and I see this first point they gave us, the ordered pair being 4, 5, and I need to think, well, what does that really mean? 4, 5. If I have my ordered pair, I'm going to write it over here. 4 we know represents the x value. 5 represents the y value, because ordered pairs are always listed as x, y. Well, but what does that mean for this relationship? The x values are talking about the days. So if we put our label on the x value, we're going to be labeling that in days. Our y value, we're going to be labeling our y value, the depth, and specifically it's in inches. So we're talking about days and inches. So if I'm looking at this point, then I'm looking at after 4 days, on day 4, the water was 5 inches deep. On day 4, the water was 5 inches deep. So I just took my number and connected it with each of the labels. Day 4, 5 inches. So then, what about if I want to look at this point right here? Its ordered pair was 8, 2. How could I describe that ordered pair in relationship to this scenario, the depth of the water? Well, again, 8 is our x value. So on day 8, the water in the vase was 2 inches. So I'm just putting those labels with my mathematical numbers. So I wanted to give us just a little bit of a background on how to read those points, how they related to the graph. So now let's go look at what the questions are asking us. First, they want to know, what is the slope? Well, the slope we know is the change in y over the change in x. We like to use a strategy called rise over run when we're talking about graphs. And one of the first things that I notice about this graph, I notice it's going down. So what kind of slope is that? Right, it is a negative slope. So it's a negative slope, so I know I'm going to go ahead and put that negative there. And then I need to pick just 2 pretty points. There's 3 points listed. There's the 2 we made, and there's one up here. Maybe I'll use these bottom 2. All right, so first let's consider, what is our rise? What is the change in the y values? Our vertical change. We changed by 1, 2, 3. So my rise, my change in y was 3. My run, my change in x was 1, 2, 3, 4. So now I know my slope is negative 3/4. But remember, we're going to have to describe it, so let's go ahead and put our labels on it. My y value, 3, is referring to what? What was the y value talking about? Inches. So that's 3 inches. The x would be 4 days. So I need to take, they want to know, how does this apply to this scenario? So I need to take all of this information and I want to put it into a sentence, into a describing sentence. Well, negative Well, what does that mean? Is the water in my vase, is it going up or going down? Right, negatives go down. So we could say the water is decreasing. Or you could even say the water is going down. Well, at what rate? Well, we found that right here, the slope, the rate of change. 3 inches every 4 days. 3 inches every 4 days. So the water is decreasing 3 inches every 4 days. Well, let's go back up here and look at our example. On day 4, it was 5 inches. 4 days later, on day 8, I need to go down 3 inches. Well, what's 3 inches from 5? It is 2 inches. So see, our rate of change, our slope, is how we can describe it. It is decreasing 3 inches every 4 days. All right, so now let's go look at the y-intercept. Well, what is the y-intercept? Remember, it's where the line crosses the y-axis, where the graph crosses the y-axis. Our y-intercept is right here at 0, 8. Well, what does that really mean? How does that apply to the scenario? Well, if I know that my x value is days, my y value is inches, would we really say on day 0 it's 8 inches? No. What is day 0? That's just where we started, right? When we filled that base up, where did we start? We started with 8 inches. So, the vase was originally filled with 8 inches of water. There's a whole bunch of ways we could have said it. The vase was originally filled with 8 inches of water. In the beginning, there was 8 inches. We started with 8 inches of water. All of those that relate to a starting point. The original value of water in that vase at day 0 when we first started was 8 inches. All right, let's turn the page over and look at another example. Now, what's this example talking about? It's talking about a hawk diving towards prey. So we've got this hawk flying along. There we go, he's flying along. And then all of a sudden he's flying along, and then he swoops down, and he has to pick up his prey. Maybe he found something yummy to eat, a fish in a pond. So he's got to dive down to get that fish. So let's look at question number 1. Describe, so we know we're going to be talking in words. Describe the hawk's flight. So when we look at the graph, that's pretty easy to tell. Is the hawk flying upwards or going down? Is the hawk ascending or descending? He's going down because our slope, we know, is going to be negative. And we want to look at the rate of change. This rate of change, what does that mean? Rate of change mathematically refers to the slope. How fast is he diving down? What is that slope of that line that shows he's diving downwards? So we can describe, so we already know the hawk is diving down or the hawk is descending. But now we need to know at what rate is he descending. So again, we have to look for the slope. So I'm going to use this place up here to work out our slope. So again, we know slope is change in y over change in x, which is our rise over our run. We need 2 good points, 2 pretty points. They gave them to us right here and right here at 360 and at 630. So we can draw our little helper triangle. And we need to calculate, how is it rising? How is it running? Well, first of all, I know it's negative. We already established that it's going downward, so it's a negative slope. And then the rise. The rise looks like it's going up by 1, 2, 3, but if we notice, what is the y values counting by? The y-axis is counting by tens. 10, 20, 30, 40, 50, 60, 70, and so on. So instead of counting by 3, we need to count, or counting by 1s, we need to count by 10s. So that would be 10, 20, 30. So my rise is 30. Now on the x-axis, we're still counting by 1s. If I fill these in, you can see we're counting by 1s. So that's just 1, 2, 3. So negative 30 over 3. And we can simplify that to negative 10 over 1. But remember, we want to put the labels there. So negative 10, our y value is talking about which label? The altitude on the y, specifically the feet. The denominator, the change in x, our x-axis is labeled time in seconds. So now we need to put all of this into our describing statement. We already have the negative sign taken care of by the hawk is descending. Now we just need to add in this rate. So the hawk is descending 10 feet per second. I could have also said 10 feet for every second, 10 feet each second, 10 feet for 1 second, 10 feet per second. We can use the word per because our denominator is 1. It's a unit rate. But now look at question number 2. How high was the hawk flying before it started? Before it started at 0 seconds, 0 seconds, how high was the hawk flying? Well, at 0 seconds, when x value is 0, follow it up, our line hits right here at 90. So he was going 90 feet before he started his dive downwards to get his prey. And how do I know this? Because my y-intercept, which is where we started, my y-intercept was at 0, 90. So at 0 seconds, we were at 90 feet. Oh, whoops, I'm not on the page. There we go, sorry. We know this because our y-intercept, the value where we started, was 0 seconds, 90 feet. All right, let's look at one more example. In this example, Shane bought a new tree to plant in his backyard. Shane used the table below to record the tree's growth. Use the table to answer the following questions. Well, first, let's understand our table. In our table, it says at year 2, 2 years after he bought the plant, the height was 32 inches. 3 years, it was 44 inches. After 4 years, it was 56 inches. And remember, in our table, the first value is always x. This one is y. All right, so our question asks us, question number 1, describe, so we have to use words, the rate of change. Rate of change mathematically refers to what? Yes, it refers to the slope. So, describe the rate of change in growth from year to year. So, I got to find the slope from this table. Remember, slope is change of y over change in x. Well, what's happening in my y values? From 32 to 44, we're going up in value, so that's positive. We're going up 12. So my change in y is a positive 12. Over here on the X side, from 2 to 3, we're going up, positive 1. So 12 over 1. So if we put our labels, 12 inches for 1 year. So how can we write that into a describing statement? Right here, it's positive. So is the tree growing or is the tree shrinking? Yeah, it's growing. So the tree is growing 12 inches per year. You could also say the tree grew 12 inches per year. 12 inches each year, 12 inches every year. Could I also say the tree grew 1 foot per year? Is 12 inches the same thing as 1 foot? Yes, it is. All right, so the last question, how tall was the tree at the time of purchase? Well, our table only started recording at 2 years after purchase. So how am I going to figure out how much was it at the time of purchase? How many years would that be at the time of purchase? Well, if I backed up my table 1 to year 1, that would be the growth after 1 year. So I'm going to need to go back even 1 further to the very beginning at 0 years time. 0 time has passed. That means right when he first bought it. So notice I was having to subtract 1 each time. So now I need to go backwards on this side of the table. So to go backwards on this side of the table, if I'm adding 12 years, what about if I want to try the year before that? What do I have to do? I have to subtract 12. So then 32 minus 12 would be 20. So that means the first year after he bought it, it was 20 inches tall. But I need to go back to 0. So I have to take away another 12 inches of growth. 20 minus 12 is 8. So here is my y-intercept, where x is equal to 0. Y-intercept was 0, 8. So therefore, at the time of purchase, the tree was 8 inches tall. So you could say Shane purchased an 8-inch tree. Or you could say, at the time of purchase, the tree was 8 inches. When Shane bought the tree, it was 8 inches tall. Okay? Several different ways that you could describe it in words, but it means the same thing. All right, make sure you have these notes secured somewhere where you can reference them as you're studying and working.